Hello everyone, I Dr. Nilima Goswami from SGI Bhopal, professor in SIRTS Pharmacy. Today I'm going to start spreading coefficient uh, that comes under the surface tension. Spreading coefficient. Uh, what is spreading coefficient? When you drop a oil such as oleic acid, castor oil or some oil placed on a surface of water, it will spread up as a film. Okay, the ability of that one liquid to spread over another is calculated as a spreading coefficient. Okay, if the spreading coefficient is spontaneous, the surface free energy of a system is reduced. So what is surface free energy? What is surface free energy? That surface free energy is based on work of cohesion or work of adhesion. So that is surface free energy. So what is surface free energy? Surface free energy is W is equal to gamma delta A, that is surface free energy. ये हम previous discuss कर चुके हैं, where W is the work done or surface free energy increase, or that surface free energy is expressed in terms of Ergs. What is gamma? That is gamma is surface tension. Surface tension, and its unit is dynes per centimeter. Then next is delta A. Delta A is area, increase in area, and which is denoted unit is centimeter square. So surface tension can be defined as the surface free energy change per unit area. तो ये हम बात कर रहे हैं सरफेस फ्री एनर्जी की. तो अभी हमने बताया कि इफ द स्प्रेडिंग इज स्पॉन्टेनियस, सो द सरफेस फ्री एनर्जी ऑफ अ सिस्टम इज रिड्यूस्ड. Hence the value of spreading coefficient is positive or 0. ठीक है, तो स्प्रेडिंग कोफिशिएंट जो है दैट शुड बी पॉजिटिव और 0. Hence the principle of spreading is important in pharmacy, such as फॉर एक्सटर्नल एप्लीकेशन. जो हम फॉर्मुलेशन करते हैं तो वो कैसे हमें उसको अप्लाई करना है, कैसे उसको एक्सटर्नल एप्लीकेशन में करना है, कैसे वो स्किन के थ्रू एब्जॉर्ब होगा. तो दैट इज द एप्लीकेशन ऑफ स्प्रेडिंग कोफिशिएंट फॉर एब्जॉर्प्शन ऑफ ड्रग एंड ऑल्सो फॉर सॉल्युबलाइजेशन ऑफ इमल्शन. तो जो स्प्रेडिंग कोफिशिएंट है इसका एक जो एक तरह से देखा जाए इम्पोर्टेंस या एप्लीकेशन जो है फार्मेसी में, इट इज़ यूज्ड है फॉर एक्सटर्नल एप्लीकेशंस में. जो हम सेमी सॉलिड या लिक्विड डोसेज फॉर्म जो यूज कर रहे हैं, इट इज़ यूज इन एक्सटर्नल एप्लीकेशन, और इट इज़ यूज फॉर स्टेबलाइजेशन ऑफ इमल्शन. And it is also used, helps in absorption of drugs through skin. So the energy involved in separating the molecule of liquid is known as work of cohesion, which is expressed as WC, that is work of cohesion is 2 delta L. And the energy involved to separate column of two immiscible liquid at the interface into two sections are called work of adhesion, which is denoted by WA delta L plus delta S minus delta LS. Here delta S is interfacial tension of sublayer, interfacial tension of sublayer or layer, or L interfacial tension of liquid interface, interfacial tension of liquid interface. ठीक है? And what is LS? That is interfacial tension of solid or liquid interface, solid or liquid interface. So that spreading coefficient is denoted by capital S. That capital S is the difference between work of adhesion and work of cohesion. तो हमारे पास वर्क ऑफ एडेशन है, वर्क ऑफ कोहेशन है, तो अगर हम दोनों इक्वेशंस को अब प्लस कर दें तो S इज इक्वल टू डब्ल्यू ए माइनस डब्ल्यू सी. ठीक है, ये हो गया हमारा डिफरेंस बिटवीन, सॉरी माइनस कर दें तो डब्ल्यू ए माइनस डब्ल्यू सी. सो तो ये है हमारा डेल्टा एल प्लस डेल्टा एस माइनस डेल्टा एल एस माइनस टू डेल्टा एल. तो फाइनली जो हमारी इक्वेशन आएगी वो आएगी डेल्टा एस माइनस डेल्टा एल प्लस डेल्टा एल एस. सो अब ये यहाँ पे हमारे जो कंडीशंस हैं उन कंडीशंस में ये हो जाएंगी हमारी कंडीशन. सपोज कि इफ फर्स्ट कंडीशन इज if delta S is greater than delta L plus delta LS, then S is positive. अगर पॉजिटिव है that shows spreading. Okay, in second condition, if delta S is smaller than delta L and delta LS, so where S is negative, so there is, that indicates no spreading, that indicates no spreading. So there are few examples of spreading coefficient at S at 20 degrees centigrade. For example, benzene having 8.8 S value, and this S value is indicated by dynes per centimeter. तो ये है S for benzene is 8.8, for ethyl alcohol is 50.4, for oleic acid is for oleic acid is 24.6, for liquid paraffin is minus 13.4. So these are the few examples for spreading coefficient at 20 degrees centigrade. So this is spreading coefficient. Then next comes to Adsorption at liquid interface. Absorption at liquid interface. Next topic is adsorption at liquid interface. Okay. लिक्विड इंटरफेस मीन्स कि जैसे सपोज टू लिक्विड से एक लिक्विड है सपोज ओलिक एसिड एंड सेकंड लिक्विड इज सपोज लिक्विड पैराफिन और सेकंड इज वाटर, दे बोथ लिक्विड्स आर इमिसिबल. तो इनको मिक्स करने के लिए हमें इन दोनों के बीच की जो इंटरफेशियल टेंशन है उसको रिड्यूस करना है. तो हम कैसे उसको रिड्यूस करते हैं? तो दैट वो जो सरफेस है उसके ऊपर भी एक एड्सॉर्प्शन, लिक्विड इंटरफेस के ऊपर एक एड्सॉर्प्शन यानी कि एक लेयर फॉर्म कर देता है दैट शुड बी इजीली मिक्स विद अदर लिक्विड. तो वो एक इमल्शन फॉर्म करता है वहाँ पे, इमल्शन. और यहाँ पे हम जो इस इंटरफेस को रिड्यूस करने के लिए जो इंग्रेडिएंट्स या जो भी एजेंट्स यूज करते हैं, that agents is known as surfactants, or that surfactants. So when some molecules and ions, when dispersed in a liquid, are partitioned in favor of the interface, so this phenomena is known as positive adsorption. This phenomena is known as positive adsorption. So the surface free energy and the surface tension get decreased in case of positive energy. Yeah, positive adsorption. So in case of positive adsorption, surface free energy and surface tension get decreased. And in case of second, that is negative adsorption, for example, in case of inorganic electrolytes, when dispersed in a liquid are partitioned in favor of bulk, this phenomena is known as negative absorption. So that negative adsorption where the surface free energy and the surface tension get increased. That is known as negative adsorption. So that is adsorption at liquid interface. तो नेक्स्ट आता है हमारा सर्फेक्टेंट्स. व्हाट आर सर्फेक्टेंट्स? These surfactants are those agents which lower the surface tension. ठीक है, which lowers the surface tension. तो surfactants are the agents which are used to lower the surface tension of liquid and also reduce the interfacial tension between the two liquids. जैसा मैंने आपको यहाँ बताया था कि when two liquids are immiscible, तो उनके बीच की interfacial को reduce करने के लिए हम लोग surface tension surfactants use करते हैं. Then these surfactants are हाइड्रोफिलिक और हाइड्रोफोबिक. हाइड्रोफिलिक इन नेचर और लाइपोफिलिक इन नेचर. ओके, they are water loving, these are oil loving. So when surfactant are placed in a water, the hydrophilic group dissolve in water while hydrophobic group form micellar. That means कि वो that forms micellar. The surfactant which have both polar and non-polar group, that are known as amplifiers. Amplifiers. Okay. Now that surfactants are categorized into 4 categories. Number 1 is anionic. Second one is cationic. Third one is ampholytic, and fourth one is non-ionic. Okay, so there are 4 types of surfactants. Let's discuss one by one. So number 1 is anionic. Number 1 is anionic. That anionic surfactants are the most common type of surfactants which are generally used as a used in pharmaceutical industries. It contains organic tail with negative charge head and small positive molecule like ammonia. So this consists of soap of alkali. This consists of soap of alkalis, amines, alkyl sulfates, and phosphates or alkyl sulfonates. These are the examples of anionic surfactants. Alkyl sulfonates. Disadvantages of anionic surfactants are they are unpleasant in taste. They are having unpleasant taste. So normally they are not used in liquid dosage form or pediatric dosage form. They are not suitable for internal use. Normally they are not suitable for internal use due to the irritating action on the intestinal mucosa. Because of its irritating action, they are not suitable for internal use. Okay. Then second category is cationic. It contains organic tail with positive charge head and small negative molecule like यहाँ पे हमारा जो molecule था वो था अमोनियम ठीक है और यहाँ पे है हमारा small charge like chloride. For example of cationic surfactants are quaternary ammonium compounds, such as citrimide, benzyl conium chloride, such as benzyl conium chloride, and next one is benzothenium chloride. So these are the examples for cationic surfactants. That benzyl conium chloride is mild in action, so that benzyl conium chloride is used in injections or especially used in ophthalmic preparations. Then third one is ampholytic. They depend on the pH of the system. That ampholytic means they depend on the pH of the system. Below a certain pH, they are cationic, while above a certain pH, they are considered as anionic, and at the intermediate pH, they act as a zwitterion. Examples of ampholytic are lecithin and N-dodecylalanine. These are the examples for ampholytic surfactants. Then last is non-ionic surfactants. The non-ionic surfactants, they does not ionize in water because their hydrophilic part consists of non-dissociated molecules. ठीक है, जैसे normally अगर हम बोल रहे हैं कि that can be dissociated into positive or negative ion, but that non-ionic surfactants are not dissociated in the water. They are pharmaceutically important. They are compatible with both anionic and cationic surfactants. They are resistant to pH change. For example, examples are glycerol or glycol esters. And best example is glyceryl monostearate. The main example is glyceryl monostearate. That glyceryl monostearate is used as a widely used as a surfactant in pharmaceuticals. Then second example is macrogol esters. Macrogol esters uh, as macrogol ester as polyoxystearates, polyoxystearates, spans, and twins. These are the examples of non-ionic surfactants. And these non-ionic surfactants are majorly used in pharmaceutical industries. So the surfactants are used in cosmetic product, uh, detergents, floor cleaners, toothpaste, shampoos. तो उसमें भी हम detergents को use करते हैं. तो surfactants are also used in cosmetics, used as home used in maintain the home hygiene such as detergents, floor cleaners. It is also used in toothpaste, shampoos, bodies shampoos. Okay. So ये just brief summary of surfactants. That surfactants are used to decrease the interfacial tension of two immiscible liquids. There are four types of surfactants. First one is anionic, second one is cationic, third one is ampholytic, and fourth one is non-ionic surfactant. Okay. So in next class we continue with HLB scale. What is HLB scale? Then what is solubilization, what is detergency, and last topic is adsorption at solid interface. So that three topics will be continued in next class.